So welcome back everybody to Global Kids Connect Mathematics. And for today's class, we will be going over the concept of percentages. And so we will begin with our first concept, as always. And so the first concept, most of you will be familiar with percentages because most of the time it is commonly used within our like day-to-day life, and you'll be pretty familiar with it. And so to begin with, the very basics. So basic percentage calculations. So the definition of a percentage translates to meaning a per hundred. So a specific value per hundred. And this is actually shown within our formula for percentages. As you can see, the percentage of a number equaling percentage over 100 times a number. And so, for example, if we are asked or if we are told to find the 30% of 40, we can say, for example, what's a good number? Let's just say 200. If we say 30% of 200, then the percentage here represents
60%.
30, yeah, and the number represents 200. And so if we plug it into our percentage of a number formula, we get percentage over 100 times the number. And so we can divide and it equals 60. And so this is an example for how the formula can be used. And so some key skills is to convert percentages to decimals and multiply. And so for a key skill, this most of the time, like in our previous example here, we said that 30% of 200. However, and so we wrote, oh, it's not going back. No worries. And so we can say that this 30 of 100 can also be written in decimals in 0.3 times 200. And if we multiply these two, we get the same value of 60. And so you can find percentages and use the formula in the fraction form or also in the decimals form. And so we'll go straight into our example question for this concept. What is 30% of 180? And so basically the same question as we did, as I explained before. So we have a percentage of a number. So let's say not a percentage, but then let's say the value that we need to find is equal to the number times the percentage on top divided by 100. And so if we do this, then it equals to, uh, you can do this using just using your hand, I guess, in a way.
50%.
Just simplify everything, get rid of the zeros, divide each side by 10, and we can say that it's 54. Or uh, what I suggest is actually using your calculator for such simple multiplication and such algebraics. Using your calculator is much faster and more reliable sometimes because most of the time, when you're practicing taking the actual mock exams and in the actual digital SAT exam, you're kind of nervous and you want to go through every question quite quickly. And these kind of very simple basic percentage calculations come up in the very beginning of the modules and the exam. And so you're actually kind of more likely to make simple mistakes because you want to go through the first part easily, quickly. But then I do advise you to, even for very basic questions such as this one, to not rush it too much and to always, if possible, double check using your calculator and such, just as to minimize any mistakes. And so I think everybody here will understand everything for this question. And the tip is to always convert the percentage to decimal for easy calculation. Uh, For some cases, this is true. First, because if you're, for example, using the decimals calculator, it could be difficult to write a fraction inside the calculator because you have to use your keyboard and such. So if you have a fraction for the percentage, like we did for 30 over 100, is for simple percentages like this, just change it to 0.3, and you can quickly add it to your decimals calculator. So another practice question. We do have a lot of material to go through, so I think we can pass on this one because basically the same question asked before, do the same steps and get the same value. And so look at the solution. Oh, so you can convert 40% to a decimal of 0.4, multiply 0.4 by the number of interest, which is 250, to get the value of 100. And so, anybody have any questions for the first part? No, right? It is quite easy, so we'll move on to the next concept. The next concept builds up on the basics of and is the percentage of one number to another. So what this means is that you're finding what percentage the part represents of the whole. So if you're given a whole number of, let's say, 200, but then you need to find out what percentage of 200, what percentage equals to 40. So when we explain it in a way such as the percentage of the part represents the 40 here, and the whole represents the 200. And so we are trying to find in the opposite way, as such, not finding the value from a percentage, but finding the percentage from a value. So we are going the other way around. And the equation for this is percentage equals the part over the whole times 100. And so we'll take a look at how this formula is used in our example question. And before we move on, one more thing is key skills to always set up fractions and convert it to a percentage like we did for our previous concept. And so we'll move on to our next example question. So the question asks, what percentage of 500 is 75? I did not edit the PPT to hide the solution initially, but then that's fine. We can go through it. So basically the same thing as is said in the solution. And so we're trying to find what percent of 75 is 500. So we use the uh, formula that we saw in our previous part here. Percentage equals part over whole times 100. And so we say the percentage, let's say the value of interest, we put it as x, is equal to part over whole. So part being 75, whole being 500, and then we multiply by 100. So that we can erase and equals 75 over 5, which then equals 25%. And so our final answer will be 25% of 500 equals 75. Any questions for this one? Oh, I think there was, sorry, my mistake.
Oh,
Not
it's
25, it is
3%.
15. Yes. I think this is a good example of not rushing when solving your questions. Like I just did, you can make simple mistakes, you know. Uh, and so even people who are, I would assume that everybody here, since we're young, we're used to simple multiplications, division, stuff like that. And so you're used to saying doing very quickly, but then I would advise you to always double check to not make simple mistakes like I just did. Anybody have any questions for this problem? Okay, if not, then we can move on. And so tip is to ensure the part is the numerator and the whole is the denominator. So what we mean is that the part, or for this case, 75, is the numerator or the value on top of a fraction. And the whole, or 70 or 500, is the denominator or the value below the fraction. So everything that I explained, as always, we can move on to our practice question. Same kind of problem. What percent of 200 is 50? And so we do the same thing. Let's say our percentage of interest is equal to, as always, part over the whole. So for us, the part will be 50 and the whole will be 200. And so we can say 50 over 200 times 100. And we can do this with our either calculator or just in your mind. We can divide each side by 100. So we get 50 over 2. And this one will equal 25%. And so we can say that 25% of 200 is 50. And as always, the solution, like I explained. Oh, and anybody have any questions for this one? I would assume not, because it is a very simple one. And so we can move on. So we come up to our third concept for percentages, which is percentage increase and decrease. And so what we mean by this is that the percentage by which a value increases or decreases relative to the original value. So this kind of means that if we are given a initial value or the original value of say, let's say 100, and then it says we increase this by 20%. So this 20% will be the percentage by which a value increases or decreases. So let's say if it increased, it would equal 120%. But then if it would equal 120, but then if it decreased by 20%, then we will say it will be 80. And so this is what we mean by increases or decreases by percentages. And so we are given a formula for this, which is percentage change equals new minus original over original times 100. So this one is for finding when we are given the initial and the final value. So let's say if we are given, like we did, just explain, if we have a initial value or original value of 100 and a changed value of 120, then we can find the percentage at which it increased by the new value or 120 minus the original value 100 divided by again the original value 100, and then we times that by 100, so that if we simplify, the hundreds will be gone. 120 minus 100 would equal 20, which is the percentage change. So we can say that and through this equation we find the percentage increase or decrease when given two values, the initial and the final. And so some key skills is to calculate the difference and divide by the original value, like shown here. And so we'll move on to our example question using these. And so the problem states Arizona's temperature rose from 95 degrees Fahrenheit in March to 132 degrees Fahrenheit in July. By how many percent did it rise? And so we're given a context question where we have to understand the context of the problem. Arizona, a location in America, and the temperature there rose from 95 to 132. So, right off the bat, we are given the original value, which was 95, and then we are also given the new value, which is equal to 132. And the question asks by how many percent did it rise? So we can use our formula in our previous slide to find the percentage change. And so we can say that the percentage change is equal to, if you remember, new minus original over original. And so we can say new value being 132 minus the original 95 and divide again by the original value of 95. And then we can multiply by 100. And then for questions like these, you would have to use your calculator. And so if I quickly use it on my own, 132 minus 95 divided by, again, 95, and then times 100 to it, we get the value of 38.95%. And so when calculating complex fractions and multiplications like this one, you can use your, I guess, own calculator if you own one, or you can use the decimals calculator provided to you. Both will work fine, and you'll be able to find the answer. And so the solution is the same as I've just explained. Then a tip for this is to use the original value as the denominator for the percentage change. Fairly simple. But then there are students that kind of confuse the equation. So some students I see they remember the equation as this, which you will get the incorrect answer. Or there are also students that kind of do the numerator correct. So they remember that it is new minus original, but then they get the denominator incorrect. And so make sure not to make this mistake and to remember the equation well, so that you don't make any mistakes when solving such questions. Before we move on, does anybody have a question for this problem? Okay. If not, then I think we can move on. So we have another practice question for this concept. And so a book's price rose from $20 to $25. What is the percentage increase? Again, we use the same method of using our formula. So the percentage change is equal to new minus original. So 25 minus 20 over original, 20, and then multiply that by 100. If we put this within our calculators, then we get the value of 25, if I'm not mistaken, because the numerator will become 5. We'll divide each side, becomes 5. 5 times 5 will be 25. And so there is a 25% increase in value. Solution, as always, is the same. And because it's the same question as before, I don't think anyone will have any questions, so we can move on. So the fourth concept of today is discounts and sales. So a discount is a reduction in the original price expressed as a percentage. And so uh, similar to our previous concepts, but then slightly different in that uh, yeah, wait, most questions that talk about discounts and sales usually give the percentage of a discount. So let's say if something is in a 20% discount, then this means like we did for increases and decreases by percentage, it means a decrease in percentage of that original value. And so the formula for using this is to is the discounted price or the changed price is equal to the original price times 1 minus the discount percentage. And so when talking about discount percentage in terms of this formula, like I said, if there is a 20% decrease in price of a certain product, then you have to change the percentage into a decimal value of 0.2. So there's actually two ways to use this formula. First one being, uh, actually it is the same way, but then some students do get confused on when they're given the discount percentage as a value that's greater than 1, because then they'll be like, do we have to multiply by 19, negative 19? But then that doesn't make sense. So what this means is that most of the time we get this one actually represents 100%. So if we minus 100 from 20, we get 100 minus 20. We get 80% of the original value will be the final value. And then when multiplying percentages into the original values, you should always change it to a decimal when multiplying. So this is the only part of confusion that students commonly face. So make sure to, I just wanted to clear that up. And then key skills for such questions using these concepts is to apply the discount or work backward to find the original price. So what this means is that when you're given the percentage, you use that percentage within the formula itself. And so I think we can move on. If anybody have any questions regarding the concept itself, you can ask now. If not, then we can move on and use this concept in a example question. So the problem states Siemens bought a sandwich for $6.76 after a 25% discount. So what was the original price? So we are given the discount amount and the changed price after the discount, and we have to find the original price. So if we take a quick look back as our formula here, we can see discounted price equals original times 1 minus discount percent. And so if we do that right here, the discounted, I guess, value is equal to original value times 1 minus percentage, the discount percent. And so we can uh, plug in numbers for the values that we do know. So we know that the discounted price is equal to 6.76. And that is equal to the original price is the value we have to find. So we just put in original here and then multiply by 1 minus the discount percentage was 25. And so we can write in a decimal form of 0.25. And so if we do this, we get 6.76 on the left equals original times 0.75. And so if we divide each side by 0.75, then we can say that the original value is equal to 6.76, running out of space here, over 0.75, which equals, if we plug it into our calculator, oh, excuse me, we get a value of 9.013. And so most of the time, SAT questions won't result in a very complex decimal answer, as it was for this case. But then there are certain rare cases where it does. Uh, when that happens, just make sure to uh, plug in uh, to the amount of decimal values that the problem either states, or uh, if you've ever taken the blue book or the college book practice exams for the SAT and seen question types where they ask you to input an answer, then there's on the left side of the screen, you can see that there are instructions on how to write down your answer. So there'll be a short section talking about for decimal values and how to write them. And College Board has a recommended method that you should follow. Uh, Maybe we could go over a practice test after our concept classes and our program, just to get a feel for what it is. And so maybe that's something we can actually do together in a later future class. And so coming back to this problem, the solution is the same. We get, and then you can round it to the second decimal point of, and then get 9.01. And so for tips regarding this problem is to divide the sale price by 1 minus discount percentage to find the original price. So what this means is that if we go back here, you can see that at the final step of our answer here, we found that the original price that we wanted, we divided the sales price, as said, 6.73, by our 1 minus discount percentage, which was 0.75. So you can also memorize finding original prices using this tip shown right here. Yeah. So that's it for this problem. Does anybody have any questions? Okay, if not, we can move on. And so we have our second practice question for this concept. And so the problem states a $40 shirt is on sale for 15% off. What is the sales price? So this is slightly different in what the problem is asking for. Last question it asked for the original price. This time we are asked to find the sales price. Finding the sales price is actually easier because we just have to say that if a shirt is originally $40 and then it is on sale for 15% off, we can say that it is 1 minus 15% is 0.15. And so if we simplify this, we get 40 times 0.85, which equals, if we plug it into our calculator, we get 34. So we can say that the sales price after the discount is a value of $34. So easier than the previous question, actually. And so, yeah, and we can see that the answer is $34. I would assume nobody has any questions for this one, right? Then we can move on. So we come to our final concept of today, which is proportions and ratios. We can see that proportions and ratios compare quantities, and a ratio of part to whole can be converted to a percentage. So the definition can be a bit confusing right now, but then you understand it when we go through example questions. So it's talking about basically everything we did until now, very similar in terms of what we're using. So you can think of percentages such as 20% as also being a proportion or a ratio. So in proportion, it will be 20 over 100. And a ratio, you can say that it is 20 to 100. So there's different ways to express percentages, but then their uses and utilization in problems are actually the same. You're finding a new value using such percentage or proportion or a ratio. So we'll go over a couple questions related to this. And so the first question shows, uh, states, an airline allows 500 milliliters of liquid. Joseph's bottle holds 2.5 liters. What's the maximum percentage that can be filled? So the question is asking for if Joseph's bottle can hold up to 2.5 liters, but the airline only allows 500 milliliters, then what percentage of Joseph's bottle can be filled? So this is fairly simple if you understand the question well. So first thing we have to do is just for easy calculation, we can convert liters to milliliters so that we get 2.5 liters equals 2,500 milliliters. And then if we know that this is the total volume, then we can say that if we can only fill up to 500, then we can show it as proportions. So we get 500 over 2,500 equaling, if we simplify, we can say it's 1 over 5. So 1 over 5 or 0.2. Or we can also say that this is equal to 20%. So you can find the percentage in different ways. You can use the formulas in previous concepts as well, and you'll be able to find 20% as well. Or you can, if the formula doesn't come into your mind quickly during the test, then you can just think of, okay, we can use proportions or ratios to help me first calculate the basic fraction, and then we can convert it into a percentage. And so there are different ways to face percentage questions, actually. And so it is really up to you. So whatever you're more comfortable with and more used to, you can use that method to quickly solve. Anybody have any questions for this problem? Okay, if not, then I think we can move on. And so a tip for this kind of question is to ensure or make sure that units are consistent before calculating any proportions. So there are students that make the clumsy mistake. You might think, for me also, when I was first studying SAT, I was very focused on like let's solve as many questions as fast as possible. This time is very short during SAT, so we have to be quick. So sometimes I actually just read a couple words and just make sure to read the numbers themselves without caring about the I guess units, which is kind of dumb of me, but then uh it is something that I learned from after making that mistake. So always make sure that your units are the same. So for our case, we changed liters to milliliters here because our the other value was also in milliliters. We're also in milliliters as here. So just make sure that all your units are the same, and in that way you can avoid making any mistakes. So we can move on to our practice question. And so the problem states a recipe needs 25% sugar of 800 grams total. How much sugar? So he's asking for how much sugar is needed for the recipe. And so we can use previous equations that we did until now in functions. So we get original value times percentage over 100 is equal to the changed value, or 8 and 200. So we need 200 grams of sugar in final. Very easy question. I just put it in there because you can th use proportions and ratios as well. But then for this problem, I think it's less of a use case compared to the previous one, but then still it's good practice. And so before we move on to our first challenge question of today, does anybody have any questions for any of the concepts we covered until now? I do not think so. Then I think we can move on to our first challenge question of the day. So we can see, let's read through it. So the problem states, at Sean's school, 35% like math, 45% like English, 10% like both, and 480 like neither. So we're given percentages and also the number of student for neither. So what is the total number of students? And so we can see that there are students that like math, there are students that like English, there are students that like both, and there are students that don't like either. And so you might be confused as to how do I find the total number of students when we're only given uh, a couple of percentages and just a single numerical value. So for questions like these, where they divide interest of students or divide a population in terms of specific categories, for this case, it's math and English, then I like to draw a Venn diagram. So what this is we have a box here. Let's say this represents all the students within Sean's school. And then we have one circle that represents the students that enjoy math. And then we have another circle that overlaps a bit with the first circle, which represents the population of students that enjoy English. Then we can say that uh, the first number we are given is 35% of students like math. And so we can say that this area, or this first circle, is represents 35%. And then we can see that our second circle, let's do a different color here, which represents the percentage of students that enjoy English, is 45%, as shown here. 45% like English. But then we can see that there's also a part where the two overlap, which is this middle part right here in the green. And so we can say that this value is actually given in the question itself because 10% are said to be like both math and English. So we can say that this green part represents 10% of the entire student population. And then our final value that we're given is that 480 students like neither. So students that do not like math or English is actually represented by what color can we use? The area that's outside here. And so this part represents a numerical value of 480 students. So we can actually, we are actually given every piece of information that we need to know. So first of all, we have to find the percentage of what percentage is 480 in terms of the total population. We are given that math is 35%, English is 45%, and both is 10%. So you may think, okay, so students that like both math and English, we just have to add up 35 and 45. But then this is incorrect because for 35, it includes this green area here, while 45% also includes this green area. So when we add
Ano,
35% and
subtractive.
45% together, then we are actually adding the green area twice. And so in order to avoid this, we minus out the green area in from this equation, from this I guess calculation. So that we get this equals 70% of students like either math or English. So what we found right now is uh if I erase things a bit, what we found is the area that is oh, here. So this whole area that excludes the students that don't like math and English is 70%. And so we can say that this 480 represents 100% minus 70% or 30% of the entire student population. So this might be slightly confusing if this is the first time you're looking at a solution like this, but then uh, this is an example of using percentage questions or proportions questions and analyzing them in a visual form instead of just numerical. And so I recommend this method if you're able to get comfortable with it for questions like this one where you're given a lot of percentages, a lot of numbers that are confusing, and you can easily get confused if you do not visually draw them in a Venn diagram like here. And so coming back to our question for our final steps, if we know that 30% of the unknown population is equal to 480, then we know two values and one value that we don't. And so we can now put this into our function that we learned previously, uh, and then say that we had the changed value, which for our case is 480, is equal to the original value times 1 minus the percentage, not percentage change actually, but then just the percentage. So we can say that it is 30 over 100 because it's 30% of the original population. And then we can divide each side. So we can, uh, I guess you can say that you move this to the other side by uh, dividing the reciprocal of this value so that you get the original value is equal to 480 times 100 over 30. Because if we multiply 100 over 30 to each side, then on this side, everything will cancel out and equal to 1. And so if we put this within our calculator, or you can do by hand, we can first get
1602.
0, yes, and then we can get rid of 3, so that we get 16, and then that will equal 1,600 students. And so this is our final answer. And so we can say that the total number of students at Sean's school is equal to 1,600. This is kind of a very confusing question and a bit difficult. Does anybody have any questions regarding how to solve it?
Okay, I got a little bit lost in the 35 plus 45 minus 10. How
Okay, I see.
does how does that equation like equal to 70% of students? How does that work?
I see. Okay, yeah, we can go back. Very good question. This is probably the part where a lot of the students get confused. Uh, Reasonably so, because it is kind of hard to grasp in your mind when you're first learning about it. But then we can go back and analyze. So let me just erase stuff right here. And then, okay. And so if we come back to the diagram that we drew, the Venn diagram, then we know that we draw a population for mathematics, students who enjoy mathematics, and then another proportion, another circle for students that enjoy English. And then there's also students that enjoy both, which is this overlapping area within the middle. And so we can say that the question says 30% of students enjoy math. And so we can say that the total, I guess, area of a circle in terms of this entire rectangle here is 35%. So if this entire rectangle represents uh let's say this is total number of students, then we can say that 35% of the total number of students enjoy math. So that will be this area here. And then we can also say that for English, students that enjoy English, the question says that 40% like English. So we can say that the area of the second circle here is equal to 45% of the total number of students. So we know these two facts, and then we're given a third fact that 10% of students enjoy both. So the 10%, or we can also say that the area in the middle here, kind of hard to see if you can see, but the green part that I'm coloring in represents students that enjoy both math and English, which is 10%, as I shown here. Let me draw it again. 10% like here. And so we need to find, and then we know that the number of students that do not enjoy math or English is 480. But we don't know the percentage, we only know the numerical value. And so if we know the number of students that do not like both, and we also know the percentage that represents this 480, then we can use these two values to find the total population. And so in order to find the percentage that of students that do not like math or English, then we have to first find the percentage using the percentage values that we know of the percentage of students that enjoy both math and English. Yeah. And so in order to find the percentage of students that enjoy both, that's why we add up, first of all, the percentage of students that enjoy math was 35%, and then the percentage of students that enjoy English was 45%. And then this is the most important part. The reason we minus 10% from this 35 plus 45, let me write down percentage of students that like either math or English is equal to. And so If we add up 35 and 45, in terms of the graph or the diagram here, then we're adding up these two circles, the areas of these two circles. But then we need to find the area of the combined area of the two circles. And so you can think of it as we're trying to find the percentage or the area of this shape, the overlapping area of the two circles for that represent math and English. And so for this, if we added 35 and 45, then we can say that 35 represented this left circle, and the 45 represented the right circle. But then you can see that the middle part here was added twice, or the area of it is calculated twice, just adding 35 and 45. And so in order to make sure the middle part or the overlapping part, the area of it is only added once, is calculated once, then we have to minus out the area of the inner part, the 10%, so that we get an area or a percentage that looks like this instead of this first shape. Uh, would that kind of help for explaining this one?
Yeah, it kind of did, but okay. Thanks for explaining. But is there like any other way that we could go about solving this question apart from this?
Uh, I would say that there may be, but then most of the time for such questions that ha like this one where there's categories where there are specific percentages and numbers, the most basic and the most, I guess, overlapping method of solving such questions involves this step in any way. So the reason why this step here is crucial and very important for solving this question is that we need to find the percentage that both like math and English. So we have to utilize these percentages shown here to find the percentage that students enjoy either math, English, or both of them, so that we can find the percentage that of students that do not like it. So uh, if you have your own time, you can maybe research, maybe you can find a solution that I'm not familiar with, and you can actually teach us later on in later classes. But then for the most common and most, I guess, uh, widely used solution is using this kind of method. And so you don't have to draw the diagram itself like I did here. I mostly did it just for sake of easy explanation and easier understanding. But then you can just skip this step entirely and just move on directly to this step and then solve and for the uh, total number of students. And so one last time coming back to your question is I currently am not familiar with other solutions for this kind of question. I'll look into it also, and then maybe we can go over it during the beginning of our next class. But then for now, this is the solution that I do recommend. Hmm. Okay. Does anybody have any more questions before we move on? If not, then I think we could move on to our next challenge question for today. And so the solution is as is, 1600. And so we now come to another challenge question. This might be the last one for today in terms of time. I'll try to go through quickly. So the problem states a 2000 cubic centimeter cylindrical tank with a 4 centimeter radius has 10 centimeters of water height. What's the water height as a percentage of the tank height? And so, first of all, it says there is a cylindrical tank. So there is a cylindrical shape, like here. and the volume of it is 2,000 cubic centimeters. So we can say the volume of this shape is 2,000 cubic centimeters. And then we're given that the radius of this cylindrical shape is 4 centimeters. And so we can say that the distance from the middle of the circle to the end is 4 centimeters. And then it says there's 10 centimeters of water height. So if the inside here is filled with water, like here, then we can say that this height or the height of the water itself is 10 centimeters. While we do not know the total height of the cylindrical itself, but then we can find it. And so how do we find it? We find it using the equation for finding a volume of a cylindrical tank, which is the base area, or the area of the shape on the bottom, multiplied by the height. And so we can find the area of the base by the by finding the area of the circle, which is pi r squared. The area of circle is equal to pi r squared. For our case, r is 4 centimeters. And so if we square this, we can write it as 16 centimeters squared. And then we know that if we multiply the area with the height, then we get volume. And so from here, we can, let me move this to the right a bit. So area times height equals volume. And therefore, we can say we know the area, which is, oh, excuse me, it was 16 pi centimeters squared. So we can say that it is 16 pi centimeters squared for the area times the height that we currently do not know is equal to the volume which we are given, which is 2,000 cubic centimeters. And so we can divide each side by the area to leave the h or the height on the left side. And so we can say that it is 2,000 cubic centimeters over 16 pi centimeters squared, which is roughly equal to, if we plug this value into our calculator, 2,000 divided by 16 times pi, so we get around 39.79 for our height value. So depending on the question, you could round the height to around 40, but then I would recommend not rounding any values until you get to your final value. So leave as much detail in your numbers right until you use do the final steps and get your final answer. After then, you can round. And so if we move on, now that we know the height of the cylinder itself, so here we can say h equals 39.79. And we know the height of the water was 10 centimeters. So going back to the what the problem asked for, what's the water height as a percentage of the tank height? So if you remember, finding a percentage is equal to uh, part over whole times 100. And so we can use this function right away. And we know that a part of the total height, which is the water height, was 10 centimeters. So we put 10 on top. And then the whole or the whole height is 39.79. And then we multiply it by 100 because it is a percent, not a proportion. And so, oh, we can say that it is equal to, once again, you can plug it into your calculator for a complex multiplication like this one to get the value of 25.13%. Or we could round it down to 25% for simplicity. And so, uh, does anybody have any questions for this one? It doesn't seem like anybody has any questions. And so, we can move on from this question now. We actually have one more challenge question, but then we are kind of running short on time. Oh, this is wait, yeah. Maybe I can leave this one to for everyone here to solve during your own time. And then maybe you can send the answers to us, to me, through the GKC email, or we can go over it during next class, in the beginning. So, due to time's sake, we won't be able to cover our final question. Uh, but then we will come back to it. If everyone wants, or if you have a question, then you can ask me during our next class, or just through email, and I'll try my best to answer any questions. And so for this will be it for today's class on percentages.